Okay, lesson four. Lesson four represents proportional relationships. All right, proportional relationships can be represented by different ways in tables, in graphs, in equations, and verbally descriptions. In a directly proportional relationship, one quantity is a constant multiple of the other quantity. We can write an equation in the form of y equals kx. You're going to hear this a lot. Y equals kx to represent the relationship where k is the constant of proportionality, or sometimes called the unit rate, what it is per one. If a directly proportional relationship is graphed, it will be a straight line. This is really important. It will be a straight line, and it will pass through the origin of 0, 0. It will also pass through the point 1k, meaning what it is per one. Per one. Like, again, the unit rate, where k is the constant of proportionality or the unit rate. So I always use COP, because who wants to write up constant of proportionality equals unit rate. All right? Okay, example. The distance a truck travels is directly proportional to the time in hours that it has been driven, as shown in the chart below. Write an equation to represent this relationship, then determine how far the truck will have traveled after driving 5 hours at that rate. Writing that equation is kind of giving you a formula of how you determine future miles and such. So time in hours is up here, 0, 1, 2, 3, 4, 5, whatever. The pattern is this. 0, at 0 time, of course, the distance traveled 0. In 1 hour, you went 50. There's your unit rate. There's your unit rate. In 2 hours, you went 100. So now in 3 hours, we know in 3 hours, at that rate, it would be 150. In 4 hours at that rate, this would be 200. In 5 hours at that rate, it would be 250. Do you see how I'm completing the table as I go across? Okay, same exact concept. Let me move this up a little. Okay, same concept. My hand's hitting the thing. All right, write an equation. The distance is always 50 times the time. So 50 is the constant of proportionality. The equation is the distance equals 50 times the time, because we figured it out from here. So 50 times 1, that's in 1 hour. 50 times 2 was 100. 50 times 3, 150. 50 times 4, 200. 50 times 5, 250. You substitute 5 for t in the equation. D equals 50 times t, or 250 miles, which we just did. The equation, D equals 50t, represents the relationship at the rate the truck will travel 250 miles in 5 hours. Could the equation y equals 50 times x plus 1 represent a directly proportional relationship? And I'm going to help you with this one. And the answer is no. Okay? The plus 1 changes everything. To be a direct proportional relationship, it has to just go by the unit rate. You just need the unit rate. The plus 1 changes it. To not a COP, constant of proportionality. That is not a constant of proportionality because of the plus 1. Okay? Very, 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 very important lesson. Learning this is all about 7th grade, because then when in 8th grade you're going to do these. These changes everything. But you got to get the 7th grade one. Okay? Just constant of proportionality. All right? Stick with me. This is getting fun. Okay. So, page 17, guided practice. Let's look. The graph below shows the amounts charged for purchasing different quantities of American cheese at a deli. Is this a proportional relationship? If so, what is the constant of proportionality and what does it mean? Okay, if it's a proportional relationship, we have 3 things to look for. The 3 things. All right? The 3 things is 1 goes through 0, 0. 0, 0, the line. The line goes through 0, 0. If it's yes, then you say yes. 2 is the line straight. Okay, then it would be yes. And 3, you find the unit rate. Unit rate would be constant all the way across. So let's look. Does the graph show a proportional relationship? A graph that shows a directly proportional relationship is a blank line. What kind of line? A straight line. Is this a straight line? Yep. That passes through the origin, and the origin is 0, 0, 0. That describes this graph. Looks good to me. If the graph is not a straight line and it does not pass through the origin, then it cannot show a direct proportional relationship. What is the constant of proportionality? Okay, so that means go to 1 on the x. So let's look at the graph. It says the cost in dollars of the number of pounds of cheese. So for 1 pound is, bingo, $3. Love it. Perfect. 1 is 3. 2 is 6. 3 would be 9. Why? Because on the graph, the constant, or the K, I don't know why they use K, don't ask me why, but the constant of proportionality here, the COP, all right, is $3. $3 per pound. You hear that? Unit rate. The constant proportionality is 3. If the question asked you to write an equation, you would write y equals 3x, substituting 3 for k in this equation, y equals kx is basically the formula or the form of the type of equation you're going to see now. And the k always represents the COP, or in our familiar words is the unit rate, what it is per 1. Okay? So, what is the constant represent? What does the constant represent? It represents the unit rate. So, it shows that American cheese costs $3 per pound. The graph blank, the graph represents a directly proportional relationship. The constant proportionality 3 shows the unit rate for the cheese. Got it? The coordinate is written 1, 3. Okay? Right? It's 1 pound of cheese costs $3. So it's sort of like this. 1 pound, $3. And that's, pound is LB, remember, that means pound. LB. And again, I don't know why. Okay? Got it? Constant of proportionality is finding the unit rate, and it can be used in a simple equation where y is generally the cost of something. The number of items is your x. This is the independent variable. Okay, and this is the dependent. Think about it. This price depends on how much you buy. Common sense. Okay, next page. What are 3 different ways to represent the proportional relationships? Oh, I'll help you here. Let's write this fast. You have a graph. You have an equation, which is y equals k times x. And the last one, what was it again? A graph equation. What page am I on? Whoops, I missed the page. Over here. Graph equation and, verbal. Using equation, graphs, or table and a table. Okay, what does k represent in this equation? And be specific. K is the constant of proportionality or unit rate. Okay? Or per 1. Think of it that way. All right, let's look at this thing. The equation y equals 6.50x relates the number of tickets purchased for a school play and the total cost in dollars. Using this equation, complete the table. Okay, so one ticket is cost in dollars is obviously the $6.50. Two tickets at $6.50. 2 times 6 is 12, and another 50 goes up to $13 for two. Right? And we're going to fill this in by multiplying. My equation here comes out to be y equals, which they gave it, 650 times the x. So if x is 3, I'm going to go 3 times 650. And my best way is to do with my calculator. 3 times 6.5 is 1950. Next one, 4 times 6.5 is $26. I should be able to do this in my head, but I'm not going to take any chances. 5 times 6.50 is $32.50. And the last is 6 times 6.50 is $39. Okay, so filling it out, there's your, using your equation and substituting for x, these numbers, you get the total cost. The table below shows the relationship between the side lengths of a rectangular pentagon and its perimeter. Use this information for questions 4 and 5. Oh, so let's see if there's a pattern. 1, 2, 3, 4, 5. So it goes up by 1. And the bottom row, 5 to 10 to 15. So it's going up by 5. So the next one here, simple, has to be 30, right? Use words to describe the relationship between the side length and the perimeter P. So as the side length increases by 1, the perimeter, as the side length increases by 1, the perimeter does what? As the side length increases by 1, the perimeter increases by 5. What is the constant of proportionality? This is wherever you have x is 1. Where x is 1, so in other words, over 1, it would be up to 5. The constant, the COP here, the constant of proportionality equals 5. Okay? So the equation, get fancy here, the equation would be y equals 5 times x. Your constant proportionality goes there. Y equals something x. What's it doing? Timesing by 5. Make sense? Okay. Let's try some examples. The graph shows how much money Felix earns depending on the number of hours he works. Use the graph for 6 through 8. Okay, so I go right to the graph and make sure I can understand the graph. So what is the graph telling me? All right. Felix's earnings, his number of hours worked on the bottom, and his total earnings is this. Well, guess what? It's a constant. It goes through 0, 0. Of course, it doesn't work. He doesn't get paid. Okay? 1 hour he made $12. There's your COP. That's your unit rate. 2 hours up 24, 3 hours up 36. Notice, multiplying by 12. So what's he getting paid? $12 per hour. Just understand how to read the graph. And now let's go to the questions. How do you know that this is directly proportional relationship? Okay, goes through 0, 0, right? And it's a straight line. Right? It's constant because it increases at a constant rate. Constant because it increases at a constant rate. What does the point 112 mean in this problem? Well, I already kind of looked at it. 1 hour, he makes $12. So his rate, the rate is $12 per hour. Write the equation in the form of y equals kx to represent this. If you can't see that, well, you need to write it. Y equals kx. K is always the unit rate. So that's what you have to fill in. Fill in the unit rate. So in this case, y equals 12x. X represents hours, y is total money. Okay, so y is his money, and x represents hours. If you get this, you got it all. This is key. Okay? Peppers at a farm stand are being sold at the cost of $2 per pound. There's the unit rate. Let's answer 9 and 10. Complete the table below to show the proportional relationship. Well, it's $2 per pound. That's easy. So 1 pound is $2. 2 pounds is 2 times 2 is $4. 3 pounds will be 6. 4 pounds will be 8. 5 pounds will be 10. 6 pounds will be 12. Create a graph, show the values from the table. Okay, so for every 1 pound, it increased. It went by $2. So 0, 0 is your start, and over 1 was $2. 2 pounds, $4. 3 pounds was $6. You see what I'm doing? 4 pounds was $8. So the rate, you notice what it's doing? It's increasing, going up 2 units. 5 pounds, 5 pounds over to 5 and went up to 10. 6 pounds up to 12, and it could keep going. And ideally you would take a ruler here and make a perfectly straight line. And that's what makes it a constant of proportionality. Going through 0, 0, making a nice straight line. Makes sense? Unit rate, so the equation here is y equals 2 times x. And try the next page.